Hello, everybody. My name is Ting Xu. Today, I would like to talk about what is nanotechnology engineering at the University of Waterloo. First of all, I would like to start with University of Waterloo territorial acknowledgement. The University of Waterloo acknowledged that much of our work takes place at the traditional territory of the Neutral, Anishinaabe, and Haudenosaunee people. Our main campus is situated on the Hardeman Tract, the land promised to the Six Nations that includes 6 miles on each side of the Grand River. Our active work toward reconciliation takes place across our campus through research, learning, teaching, and community building, and is centralized within our Office of Indigenous Relations. So, what is nanotechnology engineering? As I'm going to show you today, it's one of the engineering that can save the world. Many small objects we touch and see every day. And over in this slideshow here shows you some of those objects in nanometer scale. First of all, on the right hand side, we have a hair, and the diameter of a hair is usually around 100,000 nanometer. And then we have the human cells. The human cells has a dimension in the order of 10,000 nanometer. Bacteria are significantly smaller, and the dimension is in the order of about 1,000 nanometer. Virus is very tiny, they are in hundreds of nanometer, and in nanoelectronics, the dimension of each transistor is smaller than 10 nanometer. And for water molecules, they're significantly smaller, and they are going to be less than 1 nanometer. What is nanotechnology engineering? It is small scale, but with big impact. Nanotechnology engineering includes the science, engineering, and technology conduct at the nanoscale. And this discipline is recognized by the Professional Engineers Ontario. And this program is specifically for students with broad interest in electrical and chemical engineering, chemistry, biology, and physics. What do nanotechnology engineers do? Nanotechnology engineers use principles from chemistry, electronics, biology, and physics to design materials and devices that have interesting properties. And we also design systems with dimensions on the nanometer scale, measured it in billionth of a meter, to direct control of matter on the atomic scale. We have developed a animated cartoon for the students that describe what is nanotechnology engineering, and actually is posted on our website, but I'm also going to play it over here.
What is nanotechnology engineering? Nanotechnology engineering is the ability to see and control individual atoms and molecules. With this astounding ability, nanotechnology engineers can manipulate and create new materials, structures, devices, and systems. Nanotechnology engineering is a new engineering discipline recognized by Professional Engineers of Ontario. It's new because it has only been around since the 1980s, when technology progressed enough to be able to see at the molecular and atomic level. That is when it was discovered that at the nanoscale level, materials have unique properties such as greater strength, lighter weight, ability to control the light spectrum, and far greater chemical reactivity than their easily visible, larger scale counterparts. These tiny but mighty superpowers allow nanotechnology engineers to develop new materials that behave in astonishing ways. Every industry in our modern economy now uses some form of nanotech for innovation. Nanotechnology engineering has allowed us to create novel vaccines against the global COVID-19 pandemic, and we are looking at similar ways to treat cancer and other diseases. In the Nanotechnology Engineering Program at the University of Waterloo, you will study chemistry, chemical engineering, electrical engineering, physics, biology, and design. With this knowledge and leading-edge equipment in Waterloo's nanotechnology engineering labs, you will be making a big impact using some of the universe's smallest components.
Now, let's look at two of the major achievements by the nanotechnology recently. First of all, nanotechnology enabled COVID-19 vaccine that may have saved millions of lives. The COVID-19 vaccines consist of synthetic mRNA molecules and is being encapsulated by the lipid molecules and form in lipid nanoparticles, and it encapsulates the mRNA, and this becomes our COVID-19 vaccine. It's being injected to the body, and the nanoparticles with the mRNA molecules inside are delivered into the cells and induce an immune response. Let's look at another important contribution by the nanotechnology engineering. This is integrated circuits, or most people call it chips. This is a nanotechnology that we cannot live without. Each advanced transistor dimensions is smaller than 5 nanometer, and there are billions of them on each chip. And imagine a day without the silicon chip, or the chip doesn't work. That would bring us back to the Stone Age. There will be no more cars, no phones, no Instagrams, or even access to TikToks. So this is one of the reasons nanotechnology is very important to our life and today's society. Now, let's look at the areas that nanotechnology engineers can make impacts. In the optical engineering sector and also biotechnology sector, the nanotechnology engineers will work on the biosensors, COVID-19 vaccines, drug delivery, and also medical imaging. In the computational engineering sector, the nanotechnology engineers can work on software modeling to predict outcomes of certain events or device. In electrical engineering sector, the nanotechnology engineers will work on semiconductors and also develop new integrated circuits and also manufacture nano instrumentations. In the engineering sector, one of the examples for the nanotech engineers is to work on batteries or photovoltaic devices. The nanotechnology engineers also make big impacts in materials sector, and this including constructions, new fabrics, and cosmetics material. So these are just examples of the sectors and area nanotechnology engineers can make impact. So what do nanotechnology engineering students learn? So in the first 2 years, it covers about curriculums, and the third and fourth year, the student can pick their focus by taking elective courses and specialized labs. During the first terms, the students may take Calculus 1 for engineers, linear algebra, societal and environmental impact, introduction to computer programming, chemical principles, and they will have hands-on laboratory to develop the skills. And then they will take classes in computer aided design or CAD, and they also have labs for 3D printing. In the upper years, the students will specialize in their own interests, and they will have courses in organic and biochemistry, nanotoxicology, nanoscale biosystems, nanostructured materials, polymers, soft materials, advanced calculus, nanoscale computer simulations. These are simulations of what happened in nanoscale, and semiconductor physics, nanoelectronics, nano microfabrications, nanoprobing, and lithography. So they can know how to make integrated circuits or some other small scale devices. So what are the career prospects for the nanotechnology engineering student after they graduated? This pie chart over here shows approximately 53% went into the industry after they graduated. About 39% continue their study for advanced degree, such as master degree, PhD degree, to become a doctor, a dentist, or lawyer. And about 8% of them will form their own startup company. So after they studies at University of Waterloo, they come up with this great idea while they're studying, and they decide to continue the path and form their own company. Now, let's look at the employment sectors that the nanotechnology engineering students went into after they graduated. About 15% of them joined the semiconductor and electronics sector. Another 15% of them are in the software and IT industry. And 13% of them are in healthcare and pharmaceuticals. Another 13% of them is in the entrepreneurs. 10% went into the manufacturing. There are about 8% are in the business and finance sector. 7% are in consulting. As you can see, the nanotechnology engineering program prevents students to go into a diverse career path. Why choose nanotechnology engineering program at the University of Waterloo? The home of the nanotechnology program is inside Mike and Ophelia Lazaradis Quantum Nano Center. A photograph of this building is shown on the right-hand side, and we have classroom and lab in this building. This is a unique program in Canada with a dedicated clean room, about 1,000 square feet, for the undergraduate students. It consists of a lithographic facility for micro and nano device fabrications, a photograph of one of the silicon substrate with pattern printed on it. It shows on the right-hand side in our fab. There are about 500 nano students studying in the program. It's a mature program, and the students pursue jobs in the industry or go to graduate school, professional school, or even form their own startup companies.
Hi everyone, I'm Jen Coggin, the lab manager here for the Nanotechnology Engineering Program. And I just want to give you a little bit of sense of our amazing lab facilities that we have here for the program. In every semester that the students take, we have dedicated lab courses. So we're showing our students different techniques, skills, and we really dedicate a lot of our time to teaching our students about this. So if your students are really into the hands-on learning and lab type of parts of a course, then they would really enjoy this program. You can look here at the bottom of the screen at our QR code, and if you scan that, you can actually take a recorded video tour of our full lab spaces here on campus. So our program does span 4 themes, the first being nano-engineered materials. So the students from first year and second year learn the fundamentals of chemistry, so chemical synthesis. They take organic chemistry and then move on to learn about polymers and plastics. And in the upper years, start working with actual nanoscale materials, so carbon nanotubes, graphene, and the applications of these, so things like batteries and other applications. Another theme of our program are nanobiosystems, and the students will learn about biochemistry, and in upper year labs, do applications such as biosensors, targeted drug delivery, and design and the application of DNA and peptides. Another theme is nanoelectronics, and you can see here on the left, we have a dedicated lab space for electronics courses where they learn basic circuits and then move on to learn and make chips, different electronic devices, and applications such as solar cells, display technologies, and the like. I think this photo actually shows quite well that our lab courses tend to be broken down into sections. So our students would only be about 20 in a room like this, up to 20, and the students tend to work in pairs. So they have that interaction and cooperation of working on a lab course together. On the right here, I've shown example pictures of our clean room. This is our 4th theme, so not clean rooms per se, but just instrumentation. So they learn different instruments that they can look and manipulate things at the nanoscale and also produce devices. So this is what a clean room's for. Clean room just meaning that the air is filtered. We don't want any small particles like dust or skin cells, things like that, contaminating the devices that are being prepared in these labs. So when the students in all of our engineering programs reach their fourth year, they're tasked with doing a capstone design project, or AKA their final year project. And these are really exciting opportunities. They form groups on their own, come up with their very own ideas, and then build, test, and prototype based on that design. They come up with amazing ideas. And a lot of these are really innovative, groundbreaking, especially in the Nano program, which is quite innovative. A lot of new and multidisciplinary projects come out of these, and they do lead to startup companies. So here at the University of Waterloo, we have a great ecosystem that's set up to support any of our students who decide to go on and use their project to create a startup company. Some examples here are Scope, Nerve, Alchemy, Salient Energy. Probably have between 30 and 40 companies at this point, and you can take a look at more information on the link shown below. So I have a few, two videos to share with you that will just give a brief glimpse into two different of these fourth year projects that our students have completed. So I will show the first one now.
I'm Kalina, and me and 3 other group members form Removal Inc.
Sorry about that, I'll try again.
I'm Kalina, and me and 3 other group members form Removal Inc. So 47% of the US millennial population has a tattoo. So that's 39 million people right now. And a poll was put out, and 23% of those people already regret having a tattoo. So that's 9 million millennials only in the US. And the current methods for tattoo removal currently are laser tattoo removal, and that is extremely painful and very inconvenient and also very expensive. So we wanted to try and come up with a solution that would address these issues. And so what we've made is a microneedle patch that has an array of 100 microneedles, and I will show you how it works. So here's the patch with the microneedles, and it is inserted into the upper layer of the skin, which is the epidermis, above the nerve and blood vessels. And then it releases an enzyme that degrades the ink and decolorizes it. And then the patch backing is removed off of the skin, and your tattoo is gone. So that's the principle. Okay, so first we split up the making of the microneedle patch into 2 separate areas. So the first 2 of us were working on the actual making the microneedles. And so we optimized the length of them so they wouldn't be too long and wouldn't touch the nerves and the skin. Whereas the other 2 group members were working with the lactase enzyme to actually decolorize the ink. And then we brought those 2 things together into the patch, and then we were able to decolorize Allura Red ink with it. So you can see here that we are able to go from the red solution to a clear solution. And because it works in solution, we wanted to see how it would work in a semi-solid because that's more skin-like. So we also tested it in agarose gel, and you're able to see that it clear in the middle, which is where the patch was. In the future, we plan, so the enzyme that we use is very specific to this Allura Red dye. But for actual tattoo inks, they're nanoparticles, so we need to degrade them first. So we need other enzymes that are capable of dissolving these dyes as well, because this is what's actually in a tattoo. So we're planning on putting multitude of enzymes into the patch, and so then it's placed on the skin, and then it will degrade or decolorize most of those dyes. We want to thank Ex Vivo for supplying us with the microneedle patch. It really helped us make the microneedles in the first place. We also want to thank our advisor, Dr. Valerie Ward, for supplying us with so much information for our project, and for other professors on campus that also helped us.
Great, so we'll move on to showing our second video.
we built an electrochromic flexible color changing fabric. And essentially what this means is that when we apply a small voltage to our device, it's able to change color. And the fundamental principle behind this is that it undergoes a redox reaction, shown here. And so essentially by applying a voltage, we are able to hit a redox reaction. That redox reaction results in the device changing from one colored state to another. This device in particular is able to transition between blue and transparent. And these sort of devices are called electrochromic devices, but primarily they've been built on very brittle substrates, electrodes, sorry. And ITO is a common example. And the main challenge is that since they're brittle, they can't be flexed, and they're really limited in their applications as a result. So what we decided to do was replace the ITO and figure out a different way to sort of tackle that problem. And our solution was using silver nanowires. And so we have two different architectures that we used, but the silver nanowires essentially offer us a huge advantage that they're transparent, conductive, and they allow us to essentially flex the device entirely on itself and still get performance. And so as you can see, we cycled this device for over an hour, doing 100 different cycles, and we were able to get consistent color changing performance and relatively consistent uniformity. So what we've done here is use a polyurethane film onto which we roll silver nanowires on top of. We then spin coat our electrochromic material called PDOT, and we use in between an electrolyte that allows for, that serves as an ion storage layer and sort of mediates the electron flow. And then we've got another half of the PDOT. And then finally, we've got copper contacts that allow us to probe it. And once you've sort of created that architecture, we hot press it onto a fabric. And then the entire device is enclosed by a polyurethane film. We think potential applications of long term could be anywhere from the cosmetic industry in terms of, fashionable clothing, to your watch strap color, for example, since it can be powered by your watch battery, or long term, which would be camouflage applications for the military. One thing to note actually is that the sort of performance we got was with very low voltages on the order of 2 volts all the way down to 0.8 volts. We were able to get consistent performance.
All right, so we really hope that you enjoyed our webinar. Thank you very much for your time. We hope you learned a little bit about nanotechnology engineering. We do have another QR code here, and this will take you to our main webpage, and you can find out even more information. For questions that you might have, you can always email us, and we'll be happy to answer any questions that you have. Thank you very much.